So chapter 5 will be a pretty short chapter because there's only 3 sections, and the first section is just basic definitions. You can look in your book for more, but I'm just going to go over the ones that you probably really need to know. Remember, again, optional are the sections, mandatory are the practice questions. So there are a good amount of assessment limits or assessment statements. So element, row, column, order, and so on. So we're going to go through most of the stuff that's here. This is what's inside of your formula sheets, determinants, inverse, and then the determinant of a 3x3, which essentially means that you might have to do this by hand and not calculator. So an element is a value within the matrix. And the way that we will note elements, it'll be something like A1, comma 1. That would be inside of this matrix here. If I had 1, 2, 4, 0, negative 1, 5, 6, 9, 1, A1, 1 would be the row, the column. So let's define row as the amount going across. Columns are the amounts going down. So in this case, there are 3 rows. This is row 1, row 2, row 3. This is column 1, column 2, column 3. So A11 would be row 1, column 1 would be this term. A 2, comma 3 would be row 2, third column. So that would be the term. So 5.2, matrix operations, adding or subtracting can only happen when the matrix or matrices are the same size. So the number of rows by the number of columns must be the same for both. Moving on. Order matters when you multiply. So they want you to find matrix C. What I mean by that is when you multiply matrix A times matrix B, it is not the same as matrix B times matrix A. So some things you need to know about multiplying. Multiplying can only happen when your, let's put it here, row of your matrix A times the column of matrix B. So that's how we talk about the size of a matrix. When you multiply by, that's supposed to be column A. So this is the row and the column of matrix A, the row and the column of matrix B. So we can essentially only multiply when these are the same. Column A must equal row B. It's the only way we can actually multiply. So if you take the example that we have here, this is 2 rows by 3 columns. This is 3 columns by 4 rows. So this means we can multiply. The result will be a 2 by 4. So I'm going to make a very large matrix and discuss how you find. So this is row 1, row 2. That's supposed to be an R. This is column 1, column 2, column 3, and column 4. So if I want to find the term that goes in row 1, column 1, I would take row 1, column 1, and I would turn the row so that it multiplies with the column. What I mean by that is this first 3 would multiply with this 3. Then you would add on the 5 and 5. So it would be negative 5 times 5. And then plus, last term would be 2 times negative 9. And obviously I'm going to run out of space. So let's see if I can just move this over a little bit and start to write smaller. So obviously I wouldn't have enough space to do them. Let's pick a random term. So I'll pick row 2, column 3. So row 2, column 3 says that if I want to multiply row 2, column 3, I would pick this row, column 3, and multiply. So that would be here. 2 times 1 plus 1 times negative 4 plus 7 times 5. So that would give me the terms I need for row 2, column 3. So you kind of get how to multiply. Essentially, you would have to do it for every single term. You would end up with 8 terms total. So the process in which I'm doing this, I would then, if I was asked to multiply straight through, I would take row 1 and multiply them each by column 1, column 2, column 3 to get all these values. Okay? Moving on, identity matrix. An identity matrix is a matrix where if you multiply a matrix A by the identity matrix, you will get back matrix A. Okay? Let's see. So example 2 is going to say the average sales of a region are given, the average selling price of each of the cameras is given. They want to know how many, find the average sales in each of the regions. So given how many I have, I want to find how much money total each region has. So I think I actually saved the solution here. So we're going to do this by matrix multiplication because you do know that the amount multiplied by the price should give us the total. So there's your matrix multiplication. You're going to multiply the prices by that entire matrix, and I have the results right here. So the total sales for each would be the values given in the last table. So that's an example of why you would use matrix multiplication. Inverse of a matrix. Formula is given to you. So show that these are multiplicative inverses. So what that means is if I multiply A, and this will give us a chance to actually do a full multiplication problem, times B, but not only do I do that, I also have to do B times A. I should get back an identity matrix. So take a look. There will be 4 terms total because this is a 2 by 2 and a 2 by 2. Since these are the same, I can multiply it and my result will be a 2 by 2. So first row, first column would give me 21 minus 20. I'm just going to write them this way. First row, second column would give me negative 35 plus 35. Oh, that's kind of nice. And then the second row, first column would give me 12 minus 12. And then the third row, third column. And just in case you are lost, I'm going to highlight and highlight. So what I'm doing for this one, I'll show my steps. I am taking the 4, multiplying by negative 5, and then adding the 3 multiplied by 7. So you should get in the identity matrix, which looks like, give myself a little more space here, 1, 0, 0, 1. Diagonals are 1, every other value is 0. So the diagonal meaning that part. So same thing here, we want to just go through. So I would do first row, first column, and I would get 21 minus 20, which is 1. Then I would get 3 times 5 plus negative 5 times 3 is 0. Negative 4 times 7, 7 times 4 is 0. And then negative 4 times 5 is negative 20. Plus 21 gives me 1. So they are inverses because my diagonal along that matrix is 1. The determinant is a formula. Determinant of a 2 by 2, that formula is given. I'm going to go and grab it for you. So there's your formula. The determinant, if you want to find an inverse, in an inverse, the determinant can never equal 0. If it does, you'd get an undefined. So A inverse, this is 1 divided by the determinant of A. Okay? So in example 5, it asked me to find the inverse. So the inverse of 4, 3, 7, 5 is equal to 1 over 4 times 5, which is 20, minus 3 times 20, 3 times 7, which is 21. And then the matrix says switch the A and D. but make the b and c negative, but keep them in their same place. So I would get 1 over -1 times 5, -7, -3, and 4. Therefore, it's just the opposite sign, so it'd be -5, +7, +3, -4 would be the inverse. Solving a system. You can solve a system by using matrices because matrix A would be the coefficients. Matrix B would be the variables. Matrix C would be the constants. And the way that we solve, we actually multiply, so I'm going to write the formula again. So A, X equals C. So we're going to multiply on the left by A inverse, which would cancel those. I'm going to multiply on the left by A inverse. So X is equal to, and actually I'm going to change these values here, or sorry, the labels. I'm going to call this matrix X, I'm going to call this matrix B, because I don't like having the C here. I am very used to having B. So you have X is equal to A inverse of B. You have to do it on the left, so you can't do B times A inverse. It will not work and give you the correct answer because multiplication order will matter. So first thing I'm going to do is find A inverse. 1 over, multiply these so I get -2, subtract the multiply of that, switch the A and B, make the A and D. So B and C are negative or opposite sign. So I get 1 over -5 times -1 minus 3, -1, 2. And -1/5 is kind of a weird value, but I believe that is correct. I didn't think I made a mistake. So my matrix for A would be 1/5, 3/5, 1/5, -2/5. Okay? And then I'm going to take that value, or that matrix, and oopsie, that's A inverse. I'm going to multiply it by B, just 3, 4. So this is a 2 by 2. This is a 2 by 1. These are the same. My result will be a 2 row by 1 column, which should make sense. So row 1, column 1, I would get 3/5 plus 12/5. And who was I kidding with all that space? Row 1, row 2, column 2 would give me 3/5 minus 8/5, which equals 15/5. And on bottom we get -3/5. Is that right? I hope so. All right.